Hello everyone. We have already learned about law of gravitation and free fall. Then we have learned about the equations of motion in the case of gravitational force. The next topic is mass and weight. Already we have learned about mass in the previous lesson or previous classes. What was mass? Mass is defined as it is the measure of inertia. This was the definition. Mass is the measure of inertia. And what was this inertia? Do you remember? Inertia means it is the tendency of the object to continue its state of rest or motion unless it is affected by an external force. So if an object is at rest, it will continue to be at rest forever if it is not affected by an external force. Okay, and if it is under uniform motion or it is moving with a uniform velocity, it will continue like that unless it is affected by an external force. Okay, and the amount of its ability to continue in that state of rest or motion, so we can measure it, is it, that is called its mass. And we know that mass is a constant. It is a constant, is it? Mass is a constant and it is the measure of inertia. And if the object has greater mass, its inertia also will be very high and vice versa. If mass is less, it will have less inertia only. Okay. And mass is a constant. It is same whether the object is on earth or any other place, outer space or anywhere. Okay, it is a constant. But what is this weight then? Weight is actually the force with which earth attracts the objects towards the earth. It is the force with which earth attracts any object towards its center or towards it. Okay, so that is the force actually. Weight is force. General expression of force is mass into acceleration. If it is gravitational force, we can write it as mass into acceleration due to gravity. Okay, so this force is called weight of the object. Here m is the mass of the object. Okay, then this mass is a constant. We understood that mass is a constant, but acceleration due to gravity may vary at different places. Means I am not talking about earth. If we go to the moon or any other planet, their acceleration due to gravity will be sometimes greater or sometimes smaller than earth. So when we go to some other planets, moon, etc., our weight will differ because acceleration due to gravity will be different at these places. Okay, but if we are on earth, we can consider that g is a constant, is it, almost constant in the earth. That is why we are using weight of an object as its mass. Usually we will use weight itself as mass, is it? That is the reason, because g is almost a constant. So when you measure weight, there will not be any variation due to this acceleration due to gravity. So that was the reason. So we understood what is the difference between mass and weight and how they are actually related. Okay, then one more thing we have to learn, that is what will be our weight on the moon. Weight on the moon. Okay, for that let us consider that let a mass small m is present on the earth and on the moon. Okay, the same mass m. Okay, any object of mass m. Then if the radius of earth is small re and the radius of moon is rm, I am taking it like that, then mass of earth, let us write it as capital Me and this as mm, mass of moon. Okay, mass of earth, mass of moon. This mass is of any object that is present on the surface of earth or surface of moon. Then rm is the radius of moon, re is the radius of earth. Then we can write weight of this object, weight of this object on earth, that is WE. Weight of this object on earth, that we can write it as, how we can write? Weight means it is actually the gravitational force, is it? Weight means it is actually gravitational force with which earth or any other massive body attracts anything towards its center. Okay, so how we can write? We can write it as G. This is a universal constant, is it? G M divided by RE square. How? Because we know that F is equal to G M1 M2 divided by D square, or we can write it as R square, and we are assuming that the object is almost very near to the surface of the earth and moon. So we can replace this by R itself. Okay. Then WE can be written like this. Similarly, WM also can be written like this. G into, instead of ME we have mass of moon, mass of the object, divided by RM square. Okay. And now let us divide these two, WE by WM, because we want to compare. That is why we are dividing. Okay. So G MEM divided by RE square whole divided by this quantity. Is it? Whole divided by this quantity means this is a fraction and it will be a division. So we will multiply with the reciprocal. So it will become like this. Is it? RM square divided by GMM into M. Okay. Then universal gravitational constant, that will cancel out. M also will cancel out, and what will be remaining? ME into RM square divided by MM into RE square. The numerical values of all these quantities are given in our textbook. Actually, no need to by heart these values. We need only the simplified result only. Okay. And when you find this, you will get WE by WM as 6. WE by WM as 6. Or how we can write? WM by WE is equal to 1 by 6. This is the result given in our textbook. That means weight of an object on moon divided by weight of an object on earth will be equal to 1 by 6. Weight of an object on moon divided by weight of the object on earth is equal to 1 by 6. So what will be the weight of the object on moon? WM is equal to 1 by 6 into WE. Is it? This is actually the required result. The weight of an object when it is present on the moon, it will be 1 by 6 time of the weight of the object on the earth. So 1 by 6th means actually its weight on the moon will be less only. Let us take an example. Suppose we are taking 60 kg mass as 60 kg. Okay. If an object has mass 60 kg when it is present on the earth, if it is present on the earth and it has weight 60 kg, then what will be the weight on moon when the same object, 60 kg object, is brought to moon? Its weight will decrease. How? It will become 1 by 6 into weight of the object on earth, means 60 kg only. So this will cancel and you will get 10 kg. See? So same object, it has a mass of 60 kg when it is present on the surface of earth, and when it is present on the moon, its weight is only 10 kg. So what will happen? The weight will decrease. We can see that weight will decrease when we go to the moon. But mass will be a constant. We have to remember that mass is a constant but weight varies. Okay, thank you.